So space is sort of this nebulous term that we use. We know that we're in the atmosphere. We know that satellites are in space, but how do we define the edge of space? Where does space begin? Is space a vacuum? Is it defined by like the maximum altitude a balloon can reach? Is it defined by orbits? Or is it defined by airplanes? So is space a vacuum? The TLDR is no, space is not actually a vacuum. We know that the breathable part of the atmosphere extends up to about the top of Mount Everest, which is about 10 kilometers in altitude. We know that above that, we can't really breathe anymore, but that's not really a vacuum. The atmosphere extends actually much further than Mount Everest, or even what people might imagine. The atmosphere gets thinner and thinner and thinner and thinner and thinner, but it never actually goes away, which is interesting. The surface density is about 3 times 10 to the 19th molecules per centimeter cubed, which is a huge number. By the time you get to about 100 kilometers altitude, it's about 1,000 times less than this. So that's not zero. 3 times 10 to the 19th divided by 1,000 is nowhere close to zero. So there are still a lot of molecules there. And indeed, you can actually see this. This is a movie from the International Space Station, and you can see this green glow, and that's actually the atmosphere glowing because of some chemistry and stuff that's actually happening. You can also see sort of this red stuff that's happening, and that is the aurora. So that green band is about 100 kilometers, and that is where the atmosphere transitioned to what's called the thermosphere. And that becomes very, very, very hot above this region. Now, technically, we think of heat in two sort of different ways. Scientists think of heat as sort of the random velocity of particles. So that's basically how much random motion there is in the particles. And above 100 kilometers, there's a lot of random motion, so it is very hot. But if you went out of the International Space Station, it would not feel hot. It would feel very, very, very cold, and you would freeze to death very quickly. And that's because there aren't like a lot of particles there that can transfer that heat to you. And so you're not getting the heat from those particles imparted onto your body in a way that makes you feel hot. The aurora, which are the northern and southern lights, happen between about 100 kilometers and 300 kilometers, and a little bit higher than that. So there's definitely atmosphere there. And above 600 kilometers, really interestingly, the atmosphere is no longer considered a fluid. So a fluid is this idea that, we have water as a fluid, but also the atmosphere we talk about as a fluid, because we can use the same equations to describe water as we use to describe the atmosphere. So above 600 kilometers, we talk about it being the exosphere and not really the atmosphere anymore. So space is not really defined by being a vacuum because the atmosphere extends way out into what we consider space. So let's talk about balloons. Well, most of us know about like party balloons. So if you take a party balloon, which is made out of rubber, and it doesn't stretch very much, we fill it up to about as much as we can so it's like very tight. As it goes up, it expands a bit, and as it expands just a little bit, it will burst, right? We know that it doesn't take much to burst a rubber balloon. But weather balloons, on the other hand, are very different than rubber balloons. These are made out of latex, and they expand as they go up in altitude. They start out being like a couple meters in diameter, but then as they go up further and further and further, at about 30 kilometers altitude, they get to about 10 meters across. You can actually see them if it's a nice sunny day, blue sky out there. You can see the sun hitting the balloon and it looks like a little star in the air. They burst when they get too large, just like a rubber balloon does, but the get too large for a weather balloon is like 10 meters across. They carry instruments to measure the temperature, pressure, and humidity. They don't really spy on Americans. They're not large enough. They don't carry enough weight to actually have cameras and communication gear and stuff like that. Weather balloons are not like that. They're tracked to provide wind speed and direction. So weather balloons are launched fairly often, and they provide temperature, pressure, humidity, wind speed, and the wind direction through the atmosphere. And these are called atmospheric sounding balloons. And we launch roughly 400 of them every day across the globe. There are these things called zero pressure balloons, which, like the picture on the right shows, they're made out of plastic material and they have a hole at the bottom. And we fill them just a little bit with helium or hydrogen, and it's enough to give them some lift, but it doesn't fill them up at all. As they rise, the gas expands and the balloon grows. Eventually, the gas fills the entire balloon and it starts leaking from the hole in the bottom. Enough gas leaks out, which basically makes it so it's neutrally buoyant, and the balloon stops rising. And at that point, it can stay up at that altitude for long periods of time. Some balloons have valves that you can close, which make it so the gas doesn't leak out, and those balloons can stay up for a long period of time, weeks. And they can stay usually between 30 and 40 kilometers in the air. And they have these balloons that are like zero pressure balloons, but they're called super pressure balloons, which are very similar to zero pressure balloons. And those are ones that NASA uses to basically fly for weeks or months at a time and take scientific measurements. So in brief, balloons really can't make it to space. So above 40 kilometers, there's just not enough air to actually provide lift anymore. And so balloons don't really define the edge of space because we know that the edge of space is above 40 kilometers. So do satellites define the edge of space? Well, we know that the International Space Station is roughly between 350 and 400 kilometers altitude. It was at 340 kilometers for a while, so the space shuttle could easily reach it. Interestingly, if you look at the altitude of the International Space Station, it goes up and down a lot. And that's because at 350 kilometers altitude, there is a lot of atmosphere still there. And that atmosphere causes drag, which causes the International Space Station to lose altitude. And then a couple weeks go by, and it has lost enough altitude that they have to boost it back up. And they do that over and over and over again. Every few weeks, NASA reboosts the International Space Station. So there's clearly atmosphere up at 300, 400 kilometers altitude. And satellites orbit in this region, and we consider it to be space. The Chinese space station that was launched back in 2017 was launched to about 350 kilometers, and they did not reboost that. And so at 350 kilometers, atmospheric drag caused it to deorbit in about a year. So if you put something at about 350 kilometers altitude, it will last about a year because of atmospheric drag. Below about 250 kilometers, it only lasts for 1 to 2 months. Below 200 kilometers, it lasts only a couple of days. So below about 200 kilometers, it's impossible for satellites to actually orbit. There was a satellite that's called Gochi, or GOES, and that orbited at 250 kilometers for several years. And the way that they did that is they actually had a rocket engine on it, and they basically were having thrust all of the time to counteract this atmospheric drag. So do satellites define the edge of space? Well, they can't really orbit below 250 kilometers, or they'll burn up in the atmosphere. So that is not really the edge of space, because the edge of space is below that. They are too high, so that doesn't define the edge of space either. So let's talk about airplanes. We think of most airplanes as these commercial jets, and they cruise at an altitude of 10 kilometers, and they can reach something around 15 kilometers altitude, which is much lower than balloons. So simplistically, we would think airplanes definitely don't define the edge of space either. But there are special airplanes. They have experimental airplanes which can reach the edge of space. The X-15 was an experimental airplane which the United States government created to basically test our abilities to go to regions of the atmosphere that we have not explored before. And so this X-15 basically had these really stubby wings, and so it provided lift. So it was definitely an airplane, and it had rocket engines, so it didn't need to breathe in an atmosphere. And so the X-15 aircraft really tested the boundaries of what airplanes could do. So the X-15 was an experimental airplane that was flown in the 1960s. It was one of the fastest and the highest airplanes ever to fly. The fastest speed that it ever reached was in 1967, and it flew at a speed of Mach 6.7. So basically 6.7 times the speed of sound, which is about 7,000 kilometers per hour, which is really, really fast. It reached the highest altitude in 1963 of 108 kilometers. So the edge of space is actually defined by airplanes. It is defined as what's called the Karman Line. And the edge of space is recognized internationally as about 100 kilometers altitude. And it was written about by Theodor von Karman in 1956, and he basically discussed the balancing point of flight. As the atmosphere decreases, you have to go faster and faster and faster to actually get that lift. But as you go faster and faster and faster, you get more and more and more drag. And if you get too much drag, you could burn up in the atmosphere. And that was defined as the Karman line. And that basically is the point at which, if they go up higher than that, they won't be able to fly anymore because they would need to be going too fast. And Karman put that at around 83 kilometers. We know that airplanes, like I just said, the X-15 goes to about 100 kilometers altitude. But 83 is this Karman line, right? So it's somewhere between 80 and 100 kilometers. The Air Force actually put that 80 kilometers is the line at which, if you are a pilot and you go above 80 kilometers, you're technically considered an astronaut. But if you fly below 80 kilometers, you're a pilot. So it's somewhere between 80 kilometers and 100 kilometers is technically where space begins, and it's defined by airplanes.